Good afternoon and welcome to my talk on the topic of interstage screens in the carbon circuit. What we will discuss today is the use of wedge wire cylinders in the adsorption tanks. 15 minutes is not a lot of time to go into much detail, but what I will do is I will kick off with a general overview of a typical carbon circuit. And then we will end off with some practical considerations on how to keep these screens clean, a topic which is often overlooked. And following that, a colleague of mine will discuss an interesting case study that deals with corrosion. So the process of filtration and zinc precipitation prior to smelting is long gone. It's been replaced by carbon circuits. And it's important that we realize that we need to retain the carbon in these adsorption vessels and allow the pulp or the slurry to flow through these tanks in these carbon and pulp circuits. And therefore, the interstage screen is an important component on any type of carbon and pulp circuit. Some of the older generations or types of interstage screens include Sifbens, Bonanza screens, Cambalda screens. We've used these during my time at Anglo Gold Ashanti, but the focus today is on wedge wire cylinders. It's important to realize that these cylinders used as interstage screens can be used in carbon and leach, carbon and pulp, and resin in pulp circuits. So the wedge wire cylinder can do duty in any type of screen mechanism in these plants. I'm referring to NKM screens, the North Kalgoorlie mine screens from Australia, the Chemex Anglo-American MPS screen, as well as the Chemex pump cell plant. So the cylinder is what it says on the label. It is a cylinder that is welded in wedge wire. It comes in a variety of profiles and a variety of stainless steel grades. The typical aperture sizes range from 0.5 millimeter to 1 millimeter. And when it comes to the manufacturing, we weld them on any one of 3 custom designed cylindrical welding machines. This machine will weld the cylinder up as it rotates, and it does so in perfect symmetry from a single and a continuous strand of wedge wire. The older method of fabrication involved welding these on flat welders. And this was then followed by rolling these mats into cylinder shapes and welding it up with a continuous vertical seam. The benefit of cylindrical welding is obvious. It promises perfect symmetry with no welding joints. In order to supply the market with a wide range of sizes, calls for a comprehensive investment in tooling. And we're able to weld these cylinders in sizes ranging from 0.5 meter diameter all the way up to 1.9 meters in diameter, and we can do so in 50 millimeter increments. Just as a matter of interest, the maximum size of interstage screen that we supply measures 2.4 meters in diameter by 3.6 meters tall. This cylinder goes to a gold plant in Canada. So at Multotec, we are able to supply in excess of 1,300 cylinders per annum. The majority of these goes to gold mines in Africa, but we also export to gold mines in Canada and as far away as Australia. Carbon is an expensive commodity, even more so if you consider that it's loaded with gold up to 50,000 grams per ton of carbon. And therefore, it's important to exercise tight control on the aperture sizes on these cylinders. We are able to supply cylinders where the tolerance is 0.05 of a millimeter, that's 50 microns plus minus. These cylinders are supplied almost exclusively with wedge wire as screen media. And looking at my slide, you can see why if you look at the wedge profile of the wedge wire. You're also able to see why wedge wire makes for an ideal screen media for these cylinders if you consider the aperture relief that you see on screen. And this is essential to prevent pegging of these cylinders with near-size carbon and with grit. 5 or 6 of the wedge wire profiles from the Multotec range is suited and considered for interstage screens. So what do we look at when we select these profiles? We consider the head width. This has an influence on wear life and also on capacity. We will also study the release angle. And I believe the sweet spot is between 10 and 13 degrees, and this is required to minimize pegging of the slotted apertures. There's also practical considerations, such as weldability. As we weld finer profiles, it becomes more difficult to weld, but we are able to weld profiles down to a head width of 1.5 millimeters. These are the 4 options of stainless steel that covers virtually all of the conditions that the cylinder is likely to encounter. And I'm referring to the slurry environment. The majority of the cylinders are supplied in 304 austenitic steel, commonly referred to as 18-8 in the market. But for the more corrosive environment, we will consider 316, HSP or SAF 2205. As we move into the duplex steels, the wedge wire becomes more expensive. As I've mentioned in the following presentation, Denzel Macaulay is going to discuss a corrosive environment where the chloride content is in the region of 40,000 ppm. For that, we need one of these exotic grades of stainless steel. This is really not what you want to see on your cylinder. It's a compromised condition, a cylinder that's being pegged up with near-size carbon. Pegging is caused by not only by near-size carbon, but also by grit. It's problematic as it reduces the open area, that reduces capacity. It results in higher flow rates of slurry through the cylinder. This will accelerate wear, and it needs to be controlled. So how do we prevent this? Well, we can't prevent it totally, but we have to minimize it. I mentioned that there's 2 culprits. In terms of the grit, we advise that the aperture size of the screen panels that you employ on the guard screen from the leach should be at least 200 microns smaller than the aperture size that you utilize on your interstage screen. If your circuit is already contaminated with grit, it will have to be removed. And this can be easily done with the use of a spiral concentrator. As far as the carbon is concerned, the approach is the opposite. Screen panels that is utilized on the carbon regeneration screens that return carbon to the circuit have to be 200 micron larger than the screen panels on the Interstage screens. Once your circuit is already contaminated with grit, it has to be removed. And for this purpose, you can utilize a spiral concentrator. It's a fairly easy process given the density difference between the silica grit, 2.7, and that of the activated carbon, 0.5. So what you would like to achieve is a clean carbon inventory, and this is depicted in the picture in the slide. In the right-hand picture, you see a circuit that is badly contaminated by wood chips. And wood chips originate from the underground blasting process, and they mold even finer in the milling process, and they report to the cyclone overflow. So in this case, you will have to utilize an elutriator to remove the wood chips and adjust the upflow velocity of the water considering Stokes' law. And once you remove all of the wood chips, it's quite simply a process of removing the clean carbon from the bottom of the elutriator. And finally, in picture, you see photograph of a spiral installation, and really each gold plant should have one of these. It's fairly inexpensive. So in conclusion, interstage screens is an important component of the adsorption circuit. It's important that you select the correct grade of stainless steel and wedge wire profile. Multotec can assist with this. And finally, it's important that you keep your carbon clean of near-size carbon and grit. This concludes my presentation. Thank you for listening. Trust that you found it interesting, and goodbye for now.